Today we're looking at adding and subtracting vectors. When we are adding two vectors together, there's two methods we typically use. The first one is the triangle method. This is the one I use mostly. Sometimes I call this also the tip to tail method, which basically means we attach the tip of one vector to the tail of the other. So let's take a look at these first two vectors. One is vector A, the red one is vector B. And we're going to put them tip to tail. So if I have vector A plus vector B, we're going to translate vector B so that its tail is at the tip of A. So I'm going to redraw A. So here's my vector A over here. I just translated it over here, and now I'm going to draw vector B. And I'm going to put its tail to the tip of A. That's my vector B. And of course, you would use a ruler, and if you wanted to be really accurate, you would go ahead and measure. And then what we want to do is we're going to draw the resultant. So our resultant is actually the sum of A plus B. And our resultant is from the tail of A to the tip of B. So our resultant would go from here to there. So this would be A plus B. And again, we call that the resultant. Okay, so make sure to write that down. So again, to draw the vector A plus B, we would translate B so that its tail is at the head of A, and we would draw the resultant A plus B from the tail of A to the head of B. So in this method, you can think of adding vectors as applying one vector after the other. So we have the sum of A plus B represents the individual displacements carried out in succession. So we take a look at A first, and then put B at the tip of A. So now let's take a look at a second method. And this is called the parallelogram method. So we're going to start by using the same two vectors that we had, vector A and vector B. And in this method, we don't do tip to tail, we actually do tail to tail, okay? So that the two vectors kind of span openward. So we're going to start by drawing both A and B so that they are connected at the tails, okay? So tail to tail. So here's my vector A. Here's my vector B. And so what we're actually going to do is we are going to draw two more A's and B's to create a parallelogram. So I'm going to draw another vector A here and another vector B up here. So it's kind of like tail to tail and tip to tip so that we make a parallelogram. To find the resultant, we actually connect the tail and tail and the tip and tip together. Okay, so it's the diagonal in the parallelogram. So this here is A plus B, which is also our resultant. So some students like to use this parallelogram method because they are used to thinking about vectors as forces. So if we think about A and B both as forces, then our resultant, that A plus B, is the single force that's acting on the object and it has the same effect as the two individual forces at the same time. Again, it's up to you which method you use to find that resultant, whether you do tip to tail or the parallelogram method. Now I want you to pause the video and try this one on your own. I've given you two vectors, vector u and vector v, and I want you to determine u plus v using both methods. You should find, after you found u plus v for both methods, that you end up with the exact same resultant. Okay, so you'll end up with the same vector in the same direction, same magnitude. They should be exactly the same regardless of which method you use. Our conclusion is the triangle method, and parallelogram give the same resultant. So now we're going to take a look at some properties of vector addition. So we're going to start by taking a look at these three vectors, A, B, and C, and start with the question of finding the resultant of A plus B and B plus A. So I've redrawn A and A plus B here to draw the resultant. Lastly, so I used tip to tail, and here's my resultant, A plus B. So now I'm going to do B plus A. So I'm going to take the tail of A and put it at the tip of B. So I've redrawn it as B and then A, okay, where A's tail is at the tip of B. So when I go ahead to draw my resultant, I'm going to go from the tip of B to the tail, from the tail of B to the tip of A. And here is B plus A. Now I want you to notice that B plus A and A plus B, they're the same. Okay, so same direction. And we can also come to this conclusion by taking a look at the parallelogram method, because really if I slid these two together, you could see that we would make that parallelogram and have that diagonal in the parallelogram be that resultant. So A plus B is equivalent to B plus A. So now we're going to take a look at part B, where we have A plus B plus C, and then A plus B plus C. So I'm going to take a look at the first one, A plus B plus C, which means, of course, I find the sum of A and B first, or that resultant, and then add that to vector C. So I'm going to do that first. Since I already have A plus B, it's down at the bottom down there. I'm going to start by drawing that. So here's my A plus B. And next I'm going to draw C. So I'm going to use black for C, and C is this vector here. So it is a horizontal vector. Just going to kind of freehand that. So there's my C, and I'm going to go ahead and draw now the resultant of A plus B plus vector C. And I'm going to use yellow for that. So this is A plus B plus C. Now let's take a look at A plus B plus C. So for me, I'm going to find B plus C first. So that's what I need to do first. So I'm going to start with that to find that vector. So my B is in blue. And then my C I'll do in black. And so then I'll do B plus C in green. Okay, so now I'm going to take A and then add B plus C. So here's A. Here's B plus C. And there's my resultant, A plus B plus C. Now, they are supposed to be the same, so this vector here is supposed to match up with this vector here. And I did a pretty good job not using a ruler, freehanding this on the computer. They are the same. And again, if we were using graph paper and doing it on a grid, we would be more precise and we would be accurately showing that. But I'm hoping that even just from this diagram that you'll get the idea. So what does that mean? Well, this means two things. So the first thing is that A plus B is the same as B plus A. So those two vectors are exactly the same. So the order doesn't matter. And because that order doesn't matter, it means that vector addition is commutative. So let's write down this law. In our notes. So this means that when we have vector addition between two vectors, it means that vector A plus vector B, whatever vectors those may be, is the same as vector B plus vector A. So we also have shown, again, my sketch wasn't that great, but that we can also use the associative law. So this means that A plus B plus C, vector C, is equal to A plus B plus C. Okay.